Hello everyone, a very warm welcome to this video. Now, so far in this course, what we've seen is we've rented Amazon machines, we've set up a multi-node cluster, and we've had a cluster walkthrough. As of now, our cluster is capable of running a MapReduce program, which is great, but that's not enough. What we really want is we should be able to write SQL on Hadoop, that is using Hive and maybe Impala, also Pig. So what we are going to do next is we are going to see how to set up Hive and Impala. Before we do that, let's understand a bit about how this whole structure is going to work. In this lab, we are going to install Hive Server 2. So let's first understand the working of Hive Server 2, and we will then come back to the lab. So let's see how does Hive work. We've already seen that in the basics video. We'll have to reiterate it here so that we draw context of Hive Server 2. So typically you have an Hadoop cluster. Now in Hadoop cluster, let's say we already have a file or a folder location called as user training. As of today, for example, we have a Teradata database. Now, the first thing we want to do is we are supposed to get this Teradata data into Hadoop. Let's say in Teradata we have a table called as employee. First thing we need on our laptop is Hadoop client. Next thing we'll have is after Hadoop client is a Scoop client. So with Scoop, what we'll do is we'll connect to this database and we will get data into user training folder. So we do that. Here we have a file called as in user training folder. Or to be precise, employee will be a folder, and within employee there will be a file called as part m. So Scoop has got data from Teradata DB and dumped into Hadoop. Now that we don't know Java, we will use Hive. For that, what we do is we set up Hive CLI and we create a new folder called as user Hive warehouse. So this is the folder where Hive will host its data. We'll go to Hive and first set up a Metastore. So we have this Hive Metastore, which is amazing. So with the help of Metastore, we'll first create a blank table in Hive called as employee. And what we do is we then run a command that will dump data from this folder to this folder. So as of now, what we have is we have an employee table with this, and we can run our Hive queries. And this Hive talks to this Metastore. So this is how Hive works. Just to reiterate the flow, first we have a laptop and we have Hadoop. We then bring in Teradata database and get data from Teradata database to Hadoop using Scoop. Then to write SQL queries, we install Hive and we dump data into Hive, and then we are running a query. The problem is that as of now, this Hive, it needs a JDBC connector to Metastore. It also needs credentials of DB, and it cannot support multi-session, or you could say concurrent access for Hive. To fix all this problem, what was created was Hive Server 2. With Hive Server 2, you will connect Hive to Hive Server 2, and Hive Server 2 will connect to the Metastore and talk to the relational database. Now, with Hive Server 2, you have a central management where all the Hive clients connect to the Hive Server 2. All the clients don't have to know the Metastore credentials, and you are good to go. Hive Server 2 also brings in concurrency, and to bring concurrency, we have this component called as Zookeeper. So we will have 3 Zookeepers, and that's how Hive will bring concurrency. So this is how this whole lab is going to work. This is how the whole lab is going to work. So now let's look at how this will work in our lab. In our lab, we have 4 servers. Delhi, Mumbai, Kolkata, Chennai. As of now, we have name node, data node, node manager running, secondary name node, resource manager, Zookeeper, not Zookeeper, job history server. For this lab, what we are going to do is we are also going to install Zookeeper server on 3 machines. Here we'll install Hive Server 2, and for Impala, because Impala will also use the same Metastore, we will install Impala server on all the machines. And we will have Impala catalog, so there is already a video that talks about why these services are required, and here we are just talking of how our lab will work. So now that this is the setup that is going to be there, we already have everything that's there on the left side. It's time for us to now set up Zookeeper, Hive Server, and Impala. And that is the agenda of this particular lab. So let's get rolling. So the first thing we are supposed to do is we are supposed to install Zookeeper, and we are supposed to install Zookeeper on Delhi, Mumbai and Kolkata because we need three Zookeepers. So let's do this on Delhi. Let's do this on Mumbai. And let's do this on Kolkata. So what we've done is on 3 machines, Zookeeper is installed. What exactly is Zookeeper? The easiest way to visualize Zookeeper is like a match referee. So if somebody is acquiring a lock on a table and the other guy is basically going to access that, Zookeeper will stop it by saying that right now this guy is holding the lock. So all those concurrent issues or concurrency issues will be handled by Zookeeper. So Zookeeper has to run on 3 machines because if there is a conflict, you need to establish majority, and the only way to establish majority is you should have minimum 3 people. When there are 3 people, there would be election, and then you can set up the majority. After we've set up Zookeeper, it's time to start Zookeeper service and change the Zookeeper configuration. So let's start Zookeeper on each machine, and you'll have to start it with an ID that is going to be used in the configuration. So we are going to say our IDs of Zookeeper are going to be 1, 2 and 3. So now that we've set up Zookeeper, let's start it now. So we'll give an ID to Zookeeper, and that my ID is 1. We'll start a Zookeeper on another machine also, and we'll have it as ID 2. And in the third case, it'll be ID 3. So Zookeeper has been initialized on all 3 machines. We needed 3 instances. It's time for us to now set up or inform Zookeeper that there are 3 instances running so that they are aware of each other. Once we do that, we will ignore the heap size thing because we have good amount of RAM, and we will copy this configuration on all the machines. So let's do that. Let's copy this config. So we'll simply add this. This is our way of informing one Zookeeper about the other Zookeeper servers that are running. We'll copy this configs on all 3 machines where Zookeeper is running or where Zookeeper will be running. So what we do here is we've now entered the configuration for Zookeeper. It's time to start Zookeeper now. The command to start Zookeeper is service Zookeeper start, and Zookeeper has got started. It's time for us to verify if Zookeeper has started or not, and to do that what we'll have to do is we'll have to run a JPS command on all three servers. Once Zookeeper is started, we will now move to the Hive server setup. So let's first verify if Zookeeper is running. So it's user java latest bin JPS, and you see quorum peer main. That means Zookeeper is running here. Let's verify this on all the machines. Here also Zookeeper is running. And here also we have Zookeeper up and running. So that testifies the fact that Zookeeper is up and running on all the machines. Once Zookeeper is up and running, it's time to now move to setting up Hive and the Metastore. So Zookeeper is up. It's time to now set up Hive. What we'll have to do first is install the Hive command line tool, that is Hive, and then set up the Hive configuration. Now in our case, all our configs or all our setup we are doing on Delhi. So we will just have Hive config on Delhi. We'll have just Hive config on Delhi. So let's do that. So first thing, yum-y install Hive. So what we see is Hive is installed. So this will install Hive CLI for us. In fact, we can go ahead and install this on all 4 machines. So now that Hive is installed on all 4 machines, it's time for us to set up the configuration. So we will change Hive site.configuration and put all these configurations, because in here we'll have to educate Hive that the Metastore is in MySQL. We'll have to set that up, and those are the details that we are putting. Once we do that, we will set up the Metastore and get going. So let's update the configuration. So the first setting we'll have to change is the connection URL. Here we'll have to put JDBC MySQL So this is our way of saying that the Metastore is something that has to be there on MySQL. Next, we'll have to configure the MySQL driver. So let's do that. So here we have connection driver name, and we'll be using MySQL JDBC driver. Now that MySQL driver is configured, it's time for us to set up the username password. So the name of the setting is username. And the username will be putting Hive user. The next configuration we'll have to put is the password. It's just the same. Instead of username, we'll have to put password. Password here is just the password. The next few settings that we'll update right now are pertaining to the auto creation of schema. And here we are saying that in case schema is not existing, don't create it. You are free to throw error, but we will prefer creating it. So this is our way of educating Hive where to find the Metastore. It's true here. The next thing is auto start mechanism. then it's Hive Metastore UI. And here you should look at IP address of Delhi and give that. This is our way of exposing the Metastore so that Impala can use it. So let's get Delhi's IP. Delhi's private IP is 10.181.16.5. So that is Metastore URI. The next thing is support for concurrency and Zookeeper quorum. So let's put it Hive Zookeeper quorum, and that's Delhi, Mumbai, Kolkata. These are the three servers where we've put the concurrency, or we've run Zookeeper. So these are the three machines where we are running the Zookeeper quorum. And that brings us to the end of this configuration. The next thing is we'll have to create a directory for warehouse, that's user Hive warehouse, and we'll have to make it writable. We'll have to use -p. Change the permission. The next step is to install MySQL connector Java and create a symlink so that Hive also has access to it. So we install MySQL connector Java. The next step is to create a symlink so that even Hive should have access to it. So we'll use user share Java. The next step would be to create a symlink. User lib hive lib. So now Hive has access to the connector. It's time for us to now give permission to Delhi on the root. So let's do that. So first thing would be to start MySQL server. So MySQL has started. It's time to log into MySQL. So step one is basically to create a user for root, a user for or password for root. So let's do that. Set password Next, we'll have to create a new database for Metastore. This is where the dictionary will be created and stored. Once we create Metastore, it's time to create a new user called as Hive. And create a user on the local host also. We'll then give all the permissions. So now that permissions are given, let's exit and verify if we are able to connect to the Metastore using a user called as Hive user. MySQL-u Hive user P, password is password. So we are able to connect. We say show databases and we see Metastore. So that's done. It's time to also ensure that we are able to connect using a host Delhi. we are able to connect. Show databases, shows Metastore. So at this moment, we are absolutely perfect when it comes to connecting to MySQL. So we've installed Hive that could connect to MySQL, and MySQL is also ready. So it's time to now start the Metastore. So Metastore is a DB that does not have any tables right now. Let's create those tables. And once we create those tables, we are all set for Hive. Just to ensure what happens, let's look at the dictionary tables. You can look at the databases, use Metastore. When you do show tables, you will see the dictionary tables created for Metastore, and there are good 53 tables. So as of now, our Metastore is set up and it has dictionary tables that are required. So any table we create in Hive will eventually end up sitting here. So it's time to basically start or install Hive server and start it and see if we are able to create the tables. Once we do that, it will be time to go to Impala and make sure that Impala is able to connect to Hive and see the data. That will be it. So in the next section, it's time to install Hive Metastore and start. You have all of your information in MySQL, but it has to be exposed also. So we'll install MySQL Metastore, Hive Metastore, and start Hive Metastore. So Hive Metastore is done and it's time to start it. So that's Hive Metastore getting up. You can just check the status by also running a status command, and it's perfectly up and running. So at this moment, our Metastore is up. Just to reiterate, we have our Hive up, our Metastore up, and it's just time to start the Hive server now. So Hive client will connect to Hive server, talk to Metastore, and run queries for us. So let's start the Hive server 2. So let's install it first. So that's Hive server 2 installed for us. The next thing that needs to be done is export the Hadoop MapRed home, so that when MapReduce is running, Hive is aware the path of MapReduce libraries, and it's time to start Hive Metastore. So now once we run Hive CLI, that's called Beeline, we'll be able to see the tables and so on and so forth. Let's connect. So because we are doing this on EC2, avoid putting the username, just have default. And what you see is that connection is through. If you do show tables, right now you will see that there are no tables, and we can create a table after that. So currently there are no tables, so we are good to go. it's time for us to now try creating a table. So I'll say create table dummy ID, which is string. When we do show tables, we see dummy. The end goal of this particular lab will be that this same table dummy should be appearing in Impala. If we are able to see that in Impala, then we are good to go. So it's time for us to now, so Hive setup is 100% done. We have a cluster, we have a client where we've installed Hive, and we have a Metastore, which is MySQL. We've configured Hive client to talk to Hive server, which in turn talks to the Hive server and gets us all the information. A quick check. Now this is dummy. How is MySQL storing it? Let's first talk about that. So we are out of Hive. So MySQL-u root-t root use Metastore, and when you do select star from tbls in MySQL, you see that a table was created called dummy. A table was created called as dummy. So that's how Hive Metastore is storing the dictionary. Just to give you a quick idea, there is a table called as columns underscore v2, and this will have the same ID column. And you see the same IDs there, So that is how your data dictionary or Metastore is storing all the information. So this brings us to end of Hive. It's time to now set up Impala. So let's go ahead and set up Impala. The agenda right now is that Hive is up and running, but Impala is 30 to 50 times faster. I would like to write my queries in Impala and still be able to access my Hive table. Once we do that, we are good to go. So let's do it. So first, we will modify HDFS site.xml and add these 4 settings. We'll then start data nodes and set up Impala. Once Impala is running, we would basically try to check if we are able to see the tables or not able to see the tables. So let's do that. So let's first go to etc hdfs site.xml and in HDFS site.xml, we will need 4 settings to be there. Let's put those 4 settings. So first we are enabling short circuit by saying yes, it's true. So here we put true as our first setting. The next setting would be DFS domain socket path. and here we have a setting that says the following is the socket path suffixed by any port number that is running the service. So that's 10,000. And the last setting is enabling the metadata read. And the value is true. Once we do that, we'll have to copy this on all 4 machines and then try restarting the data node. So we'll first do it on one machine, restart the data node. If everything is good, then we replicate the settings everywhere. So sometimes while you do this, you might have a cut copy paste issue. So in this case, Mac should not be a problem, but sometimes when you copy this PDF in the CentOS VM, you may have some issues. So make sure that you are aware of the cut copy paste issues because Adobe has some issues. So here we see that the data node is up and running. What we see is that the data node is up and running. Okay, we'll have to copy these configurations on all the 4 nodes and then start working on Impala. So let's do that first. We've missed a timeout millisecond setting. Let's put it. So that we don't get timeout issues. So here we are. It's time to copy these 4 settings and pass it on to the other 3 machines. Let's do that now. So it's time to So now that we've copied this, it's time to paste it in all the machines. And we restart the data node. So let's verify that the data node has started. It's up. And we see all the services are up. Quick check, just visit Delhi5070 and you should see 4 live nodes. So that's good enough for us. Now that we've introduced the optimization with which we can simply now set up Impala. So let's do that now. It's time to now install Impala server on all the machines and Impala state store and catalog on Kolkata. So let's do that. And on Kolkata, we will need Impala catalog and state store. The next thing we'll have to do is in Impala's config, we will have to ensure that it's not running on localhost but Kolkata so that others can connect to it. And we'll also have to copy HDFS site.xml in Impala configuration. So let's do that right now. So what we are supposed to copy is HDFS site.xml. We are supposed to copy Impala Hive site.xml to Impala, and we are also supposed to change the host name in etc Impala default on Kolkata. So let's do that. And here in both the cases we should have Kolkata and not Next, it's time to copy config files. And to ensure that Impala connects to the same So Impala is now connecting to the same Metastore. It's time for us to copy these files. So let's first copy HDFS site.xml. Next is core site.xml. Third file to be copied is log4j. And the fourth file to be copied is hivesite.xml, but first we'll have to ensure that we have correct hivesite.xml. So let's first update hivesite.xml on every machine. So here we have the contents of hivesite.xml. Let's do it once again. So all the properties are here, and we can copy hivesite.xml Very similarly, and here we say space that, and we are done with having Impala. It's now time for us to start the Impala State Store catalog server on Kolkata and server on all the 4 machines. So let's do that. The next thing to start is Impala catalog. And third is Impala server. Once you see that all the services are up, you could verify it by using PSEF, where we say State Store, Catalog and Impala D. All 3 services are up and running. It's now time to start Impala server on all the 4 machines. So we've done it on first machine, that's Kolkata. Let's do it on Delhi. Let's do it on the remaining 2. Every machine just do a ps-ef grep Impala. What you should see is one service is running. You should see Impala server running. That's important. So what we have now is Impala is up and running. It's time for us to log into Impala and verify if Impala is doing great. And then we can verify if we are able to get tables in. So let's get to Impala now. So before we try out anything new, let's quickly install Impala shell and what we should do is we should run a command called invalidate metadata so that Impala could refresh and then say show tables. What we should see here is the same dummy table that we created in Hive. So this kind of testifies that Hive can be connected or Hive tables can be queried via Impala. What we can do is now you can also have an additional bonus exercise where you can get some data, create a Hive table and query it from Impala. But what we've done here is we've queried the Impala table that was, or Hive table that was created during Hive service, that was dummy. So we are able to see that. So as bonus, you can load more data and test out. But right now what we are able to see is we are able to see dummy table directly from Impala. And when we say describe dummy, we are able to get information about dummy also. So that brings us to the end of this video. In this video, what we saw is we've successfully had installed Hive. We've created a Hive Metastore. We've created tables in Hive, and we integrated that with Impala in such a way that we can query tables which are in Hive through Impala. Thanks for watching this video.